All right, so we're going to go over chapter 5, section 2, congruent polygons. So we have congruent figures. These are two figures that have the same size and shape. All of the corresponding parts of one figure are congruent to the corresponding parts of the other figure. What does this mean? You guys notice we have three little lines here on the line and the three little lines. That means that line BC right here is congruent to line ED right here. The same thing applies for these two tick marks. You notice how it's two tick marks go along with the two tick marks. The three tick marks goes along with the three tick marks. That means that line AC and line FD are congruent. You also have this one tick mark and this one tick mark. That means the lines AB and EF are congruent. The same thing applies to the congruent sign on the angles. So angle F is congruent to angle A, angle B is congruent to angle E, and angle C is congruent to angle D. We have the third angle theorem. So if two angles of one triangle are congruent to two angles of another triangle, then the third angle are also congruent. So all this is stating is that if angle A and angle C are congruent, and angle B and angle E are congruent, that means that angle C and angle F are congruent. The reason they are congruent is if you remember the addition of the inside of the triangle has to equal 180 degrees. If you add angle A and B, it's going to give you a number, and it's going to be the same number for angle D and E. So when you subtract that answer from 180, it's going to be the same whether it's for C or for F. So we have the properties of congruent triangles. We have the reflective property of congruent triangles for any triangle ABC. So if triangle ABC is congruent to triangle ABC, if you reflect it, it's the same. It's congruent no matter how you move it. You also have the symmetric property of congruent triangles, that if triangle ABC is congruent to triangle DEF, then that means triangle DEF is congruent to triangle ABC. And then you have a transitive property of congruent triangles, that if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. You guys have seen these properties before with lines and points. They're the same ones, and just instead of calling it with one letter or two, we have three because we're naming a triangle. Okay, so we got to complete with always, sometimes, or never. An acute triangle is blank congruent to an obtuse triangle. Correct. Never. A polygon is blank congruent to itself. Always. A right triangle is blank congruent to another right triangle. Sometimes. Then we have, if triangle ABC is congruent to triangle XYZ, then angle A is blank congruent to Y. Sometimes. And the last one is, if triangle ABC is congruent to XYZ, then angle A is blank congruent to angle X.
How is a right triangle sometimes and not always?
Sometimes. So they're telling us that in the diagram, this figure ABCD is congruent to the figure FGHK. And we have the picture, so we can tell that the angle K is congruent to angle D. So if we want to find X, ideally we would set it up as 4X plus 2Y is equal to 44. But in order to find X and Y, because you have to equal the 3X first, minus 6 is equal to 9. So those are the two equations you need in order to solve it. Now I'm going to just rewrite the equation up here in order to solve it a little more comfortable. So we're going to add the 6 on both sides. We're going to get 3x is equal to 15. Divide both sides by 3. And we get that x is equal to 5. Okay, I'm going to erase the equation down here. So we get that x is equal to 5. And in order to solve for y, we're going to grab that 5 and plug it into here. So 4 times 5 plus 2y is equal to 44. So we get 20 plus 2y is equal to 44. We're going to subtract the 20 on both sides. I'm going to just rewrite it up here. 2y is equal to 24.
It's way behind.
Divide both sides by 2 and we get y is equal to 12. Example 3. Maggie took the piece of fabric STUV shown in the diagram and cut it to the diagonal to make a scarf for her and her friend. Are the two pieces the same shape and size? Yes, they are. They are because we have congruent sides right here. The ones highlighted in blue and red. We also have a common angle right here. And since those angles are cut, if you guys notice, angle 3 and angle 2 are the same, as well as angle 1 and angle 4 are the same. So yes, it is congruent and the two pieces are the same. Okay, so they tell us that SV, this line right here, this line right here is congruent to RV. And they're telling us that TV is congruent to WV. And they're telling us that ST is congruent to RW. They also tell us that angle T and angle W are congruent. Now, there's only one more thing you have to state to tell me that this triangle is completely correct. Because if you were to write a proof, that would be all given. There's only one more thing that you need to state. That angle SVT and angle WVR are congruent because there is a vertical angle theorem. So if you just write angle SVT is congruent to angle WVR because they're vertical angles, that will be enough to prove that we have two angles that are congruent. So therefore we can use the third angle theorem.